bracket we have our battery, which is 15 volts, an ammeter, in this case, which is recording the total current. We have ammeter 1 and ammeter 2. Ammeter 1 recording the current passing through the 6 ohm resistor. Ammeter 2 recording the current passing through the 9 ohm resistor. Then we have a voltmeter. Obviously, a voltmeter is connected in parallel. It's different from an ammeter that we connect in series. Then we have another 2,4 ohm resistor that has a voltmeter V1. From grade 10, I think we know that we connect the voltmeter in parallel because it's got a very high resistance. So if it's connected in series, then our current cannot pass through. Then we have our ammeter. Obviously we connect it in series because it's got a very low resistance, close to negligible. So we want to attempt the questions that we are given there. The first question being, calculate the total resistance of the circuit. So we need to start with the calculation of the resistance in parallel. Then we're gonna add whatever we are getting here, the resistance, we add it to the resistor in series. Then we get our total resistance. So we're going to say, the formula says 1 over R parallel is equal to 1 over R1 plus 1 over R2. This gives us 1 over 6 plus 1 over 9. To make it easy, R parallel becomes this to the minus 1. That will give me bracket 1 over 6 plus 1 over 9 close bracket minus 1 equals, I get 3,6 ohms. That's the parallel. So R total becomes the RP plus R series. So my parallel is 3,6 plus my series. The one in series is 2,4. That gives me 3,6 plus 2,4. That gives me 6 ohms. There's the R total. So our total resistance here is 6 ohms. So we want to calculate the reading on A3, which is our total current. So we're going to use, this is our A, we're going to use, this is our B, we're going to use our Ohm's law. Resistance is voltage over current. So this is going to be total, that will be total, and that will be total. So our total resistance is 6, total voltage is 15, and we are now looking for IT. So obviously our total current will be equal to 15 divided by 6, which is 15 divided by 6. It gives us 2,5 amp. That's our current for A3. It's 2,5 amp. Then On C, we want the reading on V1. The reading on V1, that voltmeter. So we have the resistance. We also have the current, because we know that the current passing through here, our reading there is 2,5 amp. So it's the same current that is passing through our 2,4 ohm resistor. So on C, we are going to still use the same formula, where our resistance is 2,4. Our voltage is what we are looking for, and the current is 2,5. That means our voltage becomes 2,5 times 2,4. That gives us 6 volts. That's our voltage, our reading on V1. V1 reading is 6 volts. So this reading here is gonna be 6 volts. That's the reading there. So now we want to calculate the reading on V2, which is our D. So there are lots of ways of doing it. The first way is, we know that the total voltage is 15. So since we have this one is 6 volts, we can just say V2 reading will be 15 minus the 6 volts. That gives us 9 volts. That's one way of doing it. That's the reading on V2. We can still use other methods, but I think this also can suffice. Now we are moving to E. On E, we want to calculate the reading on A2. So the reading on A2, we know the voltage is 9 volts, and we know the resistance. So we're gonna say resistance is voltage over current. The resistance is 9, the voltage is 9. Then we are looking for current. Current becomes 9 divided by 9, which is 1 amp. So this is your current passing through A2. It's 1. Then the current passing through A1. The second part of E. Since we know that the total current is 2,5, so the current passing through A1 is going to be 2,5 minus 1, which gives us 1,5 amp. You can still use the method resistance is voltage over current, where your resistance is 6, your voltage is 9, and your current becomes 9 over 6, which still gives you 1,5 A. So this is current.